This is One Universe at a Time. I'm Brian Koberlein. 3D animation is captivating, and so are semi-realistic dolls and robots that sort of look like people. As these things get more and more lifelike, there's a point where they stop looking cuddly and start looking creepy. In pop culture, this is called the Uncanny Valley. On our show today is Dr. Grant Gutheil. He's an associate professor of psychology at Nazareth College in Rochester, New York. He's going to explain to us why we get repulsed by that which almost looks like us. The Uncanny Valley, this is one of those things that fascinates me because it seems to me that a lot of modern horror movies with all the rise in zombies and vampires and things like that, they're really kind of capitalizing on two things. One is predation. We don't want to be eaten.
Right.
And the other one is this Uncanny Valley, things that are unholy or not human or things like that. And I notice that when I see certain robots, for example,
right.
like the robots that are not quite right, and you really do kind of have this attitude of, I need to kill it with fire.
Yep.
So is that just an impression? Is that something cultural, or is it a real effect?
It depends on what you mean by real. Okay. But is there quantifiable, empirical, 15 studies in a row saying, oh my God, the Uncanny Valley. The Uncanny Valley is a real thing? No, that stuff doesn't exist. But
really? You're saying there isn't research on the Uncanny Valley?
I am saying there is not empirical research validating the existence of the Uncanny Valley to the extent that you would like to say, yep, that's real.
Okay.
There's a lot of talk about what could be causing it, why it might be real. And if we're going to talk about it, the thing I would say is, yep, it's real. I mean, you know it's real. That reaction you have, you feel it. It's crawling right up the back of your head. And it's like, yeah, okay, that's real. Where that comes from is a different question. What's causing it's a different question. But that's the cool thing about my business. You feel it? It's real. There's a phenomenon worth talking about. Okay. So in that sense, oh yeah, it's real.
So what would cause it then? What do you think causes it?
There are several different ideas, but I think it's a combination of a couple of things. There is that notion of predation. For one thing. So the Army's got essentially a cargo robot that it's been working on. That is essentially a torso with 4 legs that can carry god-awful amounts of crap. Functionally, it's a beautiful thing. You watch this thing run, it's terrifying. It doesn't have a head. It doesn't have a face. It's got no teeth, but it moves like the biggest, meanest, ugliest cat you ever saw in your life.
For me, it was when it slipped on ice. It's like, oh, it's just walking. It's walking. Yeah. That's cool. It slipped on ice. Kill that thing.
Yeah, that's a terrifying thing.
Yeah.
But it's a lot broader than that. I mean, the Japanese guy who came up with the notion was really onto something, I think, for a couple of reasons. Beyond that, oh my God, this scares me. There's just a simple, broad thing in human cognition. We hate being wrong, and we hate being uncertain. Right. So both those things. So the technical term for a lot of this is cognitive dissonance. So I know what I know, don't confuse me with the facts.
Right.
Couple that with something called categorical perception. All right.
Okay.
Now, in the real world, things are not categorical. In the real world, they're continuous.
Right.
So
we like putting them in boxes.
We have to. We don't even like to. It's what we do. It's who we are. Okay. So there's a classic study in this is visual perception of pictures. You start with a picture of Ronald Reagan. You got a picture at the other end of the continuum of Bill Clinton.
Right.
And through the magic of mathematics, you just do a 5% change from Reagan to Clinton.
One to the other.
And you get categorical perception. There is a point at which, Reagan, Clinton, done. That's how we like things to work. It makes us happy. Now, the problem with the Uncanny Valley is it doesn't work.
Right.
Robot, person. No. The Uncanny Valley is exactly that point where it's robot. Ah! Maybe person.
Right.
Maybe not. Oh, crap. What do I do? It violates categorical perception. It induces a profound level of cognitive dissonance, and we hate that.
Cognitive dissonance is something that to be avoided.
Yeah, you hate it in everything. You want to know what goes on. This is what's going to happen. This is why it's going to happen. I know the answer. I know why this works. And then either you find out you're not sure or you find out you're wrong.
Right.
And that happens for anything, all over human cognition. We like being certain. You know this from your students. Why don't they ask questions? Because the people might see I'm wrong.
I don't want to know. I don't want to be.
All right. I don't want to be that guy. And we fight against this every day.
Right.
Now couple that with that kind of predation thing.
Right.
And you've got an incredibly powerful effect.
Something inhuman is now after me.
And the way we tell what falls into the uncanny valley is pretty straightforward. A lot of it's got to do with faces. I mean, Polar Express creep the crap out of people, specifically because it's Tom Hanks. We love Tom Hanks. Oh my God, it's got shark eyes. It's terrifying. The eyes are wrong. They're just wrong. And developmentally, evolutionarily, I think, faces and especially eyes are crucially important for interacting with other things in the world. And it makes sense. If it's got a face, it's either going to eat you or feed you.
Right.
Faces are powerful.
Do you think it's related to the idea that, children prefer attractive faces over unattractive faces? Do you think like the uncanny valley that's really, really not attractive to the point that it doesn't look human?
It's that you're unsure. I was reading something about this where a computer scientist or a robotic scientist said you might be able to mess with the uncanny valley if the robot's really attractive. Mm-hmm. And that kind of gets to your point in that, it looks a little creepy, but it's really hot or it's really handsome. So I'll look past creepy.
The blonde from Battlestar Galactica. Okay, fine. Everybody's okay with that.
Exactly. And the thing is, she's not in the uncanny valley. There is nothing robotic about that character. Right. Absolutely nothing.
Right.
And when it falls into the uncanny valley, it gets us into cognitive dissonance about something that's fundamental. Mm-hmm. Is it human? Is it safe? Will it care for me? Will it attack me? Will it eat me? Oh my God, I don't know.
Right.
And you just lose it. And you back away. You just don't want to deal. If you can go farther, and I love the fact that that's the thing that freaks me out about this. It's a valley. It's not a cliff.
Right. You edge towards,
and then there's
I'm ambivalent. No, I really don't like that. To kill it with fire. Okay, and then I'm okay with it.
Yeah, trust me, there are a whole lot of people out there. The Japanese are deeply into this because they have all kinds of reasons for needing robotic support for their elderly population. A dozen different reasons.
And I think you see that a lot with the humanoid robots. They're very specifically, even though they're bipedal, they're vaguely human shaped.
Right.
They're very clearly not human, and they're very clearly friendly. The idea of them is they have a very bright colors and a friendly look to them, so that I may not be human, but I am not going to hurt you.
I am your friend. Asimov's 3 laws of robotics. Man.
Yes.
The man knew what he was talking about.
Right.
It's also a combination of different perceptual information. Mm-hmm. Faces is one part of it. Movement is another.
Yeah.
If you trick me, if it looks and sounds human, but then it moves and it goes, it does that mechanical motion, it's like, oh, you lied. And you lied about something fundamental.
Right.
You lied about life. I actually saw something a couple of days ago where, talking about the uncanny valley, this guy threw off like a 2-line thing of, clowns. Yeah, clowns are in the uncanny valley. Clowns are creepy.
Yeah, it's interesting that's the same type of thing.
Yeah,
I think of clowns as being friendly, but it freaks a lot of people out.
Yeah. It doesn't need to be humanoid to be friendly, and in fact, the farther it gets away from to some degree, almost the better it is. Disney's done this. I can't remember which Disney movie was it where, they've done the one with the hassock that's a dog, and the one with a blanket that is some kind of intentional creature that everybody loves. And everybody loves that.
Right.
No resemblance to humans whatsoever.
Right.
That's
even
cool.
the Disney characters.
Yeah.
They have overly large eyes, they're almost animated,
which is completely infantilizing, and babies are cute.
Right.
That's why.
But they don't look like real people,
No.
and so the animated aspects of them are perfectly fine.
Yeah, I mean, there's a comparison I saw between, I mentioned Polar Express. Mm-hmm. And Polar Express and The Incredibles came out exactly the same time.
Right.
Polar Express tanked.
Right.
The Incredibles made a god-awful amount of money. The
Right.
Incredibles looks like a cartoon. People were cool with that.
Right. Right.
The Polar Express was, it's human, but it's not. It fell right into that notion. And again, it's one part of this that's interesting for me is the degree of similarity, of overt similarity to human, doesn't matter for the anthropomorphization or the love or the caring. I mean, back during the Afghan and Iraq wars,
right.
there were a lot of bomb disposal robots. There were a lot of surveillance robots. And these bots were, fundamental parts of squad-based warfare. And the guys in the units named them.
Yeah.
Were sure they had personalities. We're sure they had feelings. There were stories about these guys saying, going back to some military robotics guy saying, you got to fix them.
Right.
And the robotics guy's looking at it like, dude, I got a brand new one that's got updated software right there.
It has to be this one.
You got to fix Bob.
Yeah.
It's Bob. And nobody saw that coming. Yeah, and we do that constantly.
It reminds me of, there was, I think, an IKEA commercial.
I love that one!
They have this lamp, and they film the lamp with sad music.
Yes, it's in the rain, I think.
And they put it in the rain, and then the guy comes out and says, some of you feel bad for this lamp. That's because you're crazy.
Yeah.
But we do. That poor lamp is being abandoned. It never moves.
No.
It's just a lamp.
It's sitting there in the rain.
Music and rain, and we feel bad for a lamp.
Yeah. And I will tell you, in that ad, it's the same kind of ad that Pixar's been using for years.
Oh, absolutely.
Yeah, it's that big spotlighty lamp.
Right.
It moves. It's got a face and a head, and it cocks to one. It's beautiful.
As long as it moves in the same way. Yeah, it reminds me, when you were talking about the Uncanny Valley, just a little bit off, it reminds me of experiences that you can have with young children, where, and I remember this with my wife. One Halloween, she went as a cat. She wore a cat, but she put painted whiskers on her face.
Right.
And when our son was about 3, he saw her and freaked. Just freaked. And it wasn't a scary face.
Nope.
It was just a couple of whiskers, but it wasn't Mom. It wasn't. It sounded like Mom, but it wasn't. And it seems like that's the Uncanny Valley on a very basic level.
That's 2-year-old cognitive dissonance right there.
I don't like this.
This is bad. Make it stop.
Yes.
Yeah, I mean, that's perfect. That's exactly what it is. And I think that's what happens in the Uncanny Valley to us at a broader level.
So why is cognitive dissonance then so problematic for us? I mean, we like putting things in boxes. It seems like that makes sense. It makes our lives easier because 90% of the time it works.
Yeah.
But what is it about the cognitive dissonance that makes us emotionally frustrated as opposed to, well, it's A or B. Couldn't we just put it in a bigger box of A or B?
Sometimes you can.
Okay.
But a lot of times the emotions get in the way, and they get in the way even in times where they shouldn't. And it's just fundamental to human nature. We hate being wrong.
Right.
How many arguments have you gotten into with your friends or watched your students get into? Hand shot first. Who cares?
Right. You have these discussions, and it's like, I'm doubling down. I know I'm outnumbered, but I'm holding my ground.
And it doesn't matter.
Right.
But you have to be right.
Right.
And there are personality differences in this. There are people who are much more prone to this than others.
Some people give up fast, and some people really double down.
As a species, as the intelligent primates we are, it's adaptive to be right. It's adaptive to have our predictions come out correctly. When they don't, I'm going to get I'm going to lose, I'm going to fall down the primate hierarchy, whatever. So we don't want to be wrong. We have a really deep emotional negative reaction to being wrong and also to uncertainty.
Right.
And again, you and I see this in classes all day long. What students want is, here are the facts, give them to me in a digestible form.
Right.
I can write them down, I can memorize them, and I can give them back.
Right.
I feel smart.
Right.
then you tell them that they're wrong, or then you tell them that they've misinterpreted a fact, or then you tell them, God help them, that memorizing the facts isn't really thinking.
Right.
And they look at you like a deer in the headlights, coupled, somehow genetically coupled with a weeping baby.
Right. And they just don't want to deal with that.
It's terrifying. It's disturbing. We hate it.
So we like our own safe little worlds, and that type of uncanny valley that's not my safe little world.
That's not my safe little world.
So I don't want it here. You're listening to One Universe at a Time. I'm your host, Brian Koberlein. We've been talking with Dr. Grant Gutheil, Associate Professor of Psychology at Nazareth College in Rochester, New York, about the Uncanny Valley. In the second half of our show, we're going to turn it around. Dr. Gutheil gets to ask the questions, and I get to answer. Today, he wants to know what all the fuss is about over a black hole in the center of the Milky Way.
What is this, and why is it making the rounds? Why are people interested in this?
Okay, so in our galaxy, like in most galaxies, there is a supermassive black hole, which is not a big deal. Most galaxies have black holes.
Can I stop you there?
Yeah.
That sounds bad.
It's not, because the thing about a black hole is if you're far enough away from it, it doesn't matter.
Even with the gravitational pull of the black hole.
This is a real common misconception about black holes, and that is black holes will suck you in.
Yes.
But they won't. If you turned the moon into a black hole, it wouldn't affect us any more than the moon's gravity does, because the amount of gravitational pull that something has depends upon its mass. If you make its mass more dense, it's still pulling on you at the same distance by the same amount.
So if there were a black hole, if the moon got turned into a black hole, it wouldn't be a moon-sized black hole. It would be a very small black hole, because the mass of the moon would be crunched down to a very, very minute.
It would still have the mass of the moon.
Right, but just in a very small...
Right.
Oh.
If the Earth collapsed into a black hole, it wouldn't suck the sun in. It would just still orbit the sun the way it normally does.
Bad for us, but not bad for the rest of the solar system.
The rest of the solar system, right.
Okay, that makes sense. Thank you.
So a black hole in the center of our galaxy is 30,000, 26,000 light years away. Who cares? There's just a mass that's that distant. As long as you're not really close to the black hole, it's the fact that you can get close to it that makes it so dangerous. The Earth, if you try and get closer and closer and closer to the Earth, you hit the surface of the Earth, and you can't get any closer to the mass.
That's it.
That's it, because the mass is huge.
Right.
If the Earth were compressed to a black hole, you could keep getting closer and closer and closer to it. The gravity would get stronger and stronger and stronger, but only because that mass is compressed so tightly.
Okay.
There's no danger or anything like that. It's just our galaxy has a black hole, a supermassive black hole. Lots of galaxies do.
Okay, so now I'm less scared, and that's good. So, no more stockpiling MREs and waiting for the end, so that's nice. But why do most galaxies have black holes at the center?
One of the big things in astronomy is how do galaxies form? Do they form by merging to create large galaxies the way we see them? Do they form first? Like gas clouds form stars, and some of those stars fall into each other to create a black hole in the center. Okay. Or is it that the gas cloud is so large that a black hole forms first, and then stars form around it, so that black holes are kind of the seeds of things? This is still being kind of debated a little bit. Okay. But what we find is that in most galaxies, particularly most things like spiral galaxies and stuff, there tend to be a black hole. There are some in which there's not a supermassive black hole in the center. But we think that that's because of things like collisions. Two galaxies come close. One black hole either engulfs one and moves on, or they get flung out of the galaxy before the stars can leave. And so you can have a galaxy that doesn't have a black hole. Okay. But most of them do. So either black holes seed galaxies, or galaxies tend to form these supermassive black holes.
So you guys have a cause and effect problem.
Yeah, we have a cause and effect problem, but, but we know observationally that most galaxies have black holes in them.
All right. So in this report that I saw, okay, I think I know the answer to this, and it's pretty obvious. The answer is, we did this to sell newspapers, or we did this to get clicks.
In terms of the popular press, yes.
Yeah, so they called it a wormhole and not a black hole because wormholes are sexy?
Well, no, they call it, the actual article is looking at, is the supermassive black hole in our galaxy actually a wormhole? So there are...
Hello, Interstellar.
Yay. Yeah. So there are these theoretical ideas called wormholes. Okay. And in a very basic level, if a black hole is the gravity pulling everything down to a center, that everything goes in and it can't come out, If you look at the mathematics of general relativity, you could create what looks like, mathematically, it looks like a bridge. It looks like an input one way and an output somewhere else. And originally, this was called an Einstein-Rosen bridge because Einstein and Rosen came up with this idea.
A wormhole is so much cooler.
Oh, yeah. Calling it a wormhole makes much sense.
Yeah, much better.
So that's what we call them now. But it's basically you have an input and an output, and they're connected together. So a lot of times in science fiction, wormholes are shortcuts between space, or they're shortcuts to another universe.
All over Star Trek.
All over Star Trek and things like that. So there are some basic problems with them. One is that if you were to set up something like a wormhole where you have, the gravity folding space inward and then letting it go out, that narrow part in between would collapse. And it would collapse so quickly that you couldn't traverse it. So it would be what they call a non-traversable wormhole.
So you need a stable wormhole.
Yeah,
I said that like I know what I'm talking about.
Right.
No, that's straight out of Star Trek, brother.
Well,
Don't let it fool you.
Well, and that's the thing, is that could you make a wormhole stable? Could you prevent it from collapsing, or would there be any condition for which it wouldn't collapse?
So you just said, could you make a wormhole stable? Is there any possibility that you could find a stable wormhole just naturally occurring?
Yeah, when I say make a wormhole, I mean in a theoretical sense.
Got it.
As a theoretical astrophysicist, I create universes, none of which are real, but I can...
but are really cool mathematically.
Cosmic power, itty-bitty office space.
There you go.
So,
my universe is this whiteboard.
Yeah, it's that whiteboard. So you can come up with ideas. So is there a situation where you could have a traversable wormhole? And people have looked at things that, what if it rotated, like a rotating black hole, what if they rotated in a certain way? What if you could fill it with some type of strange exotic matter that virtual matter or something that would cause it to open.
So create new stuff that wouldn't collapse.
Create new stuff that would do that, yeah.
All right.
And what you find is, well, probably not. And so when you look at the mathematics of wormholes, you kind of basically say, any way you fudge it, it doesn't look likely.
Right.
But the thing that's kind of interesting is that there's always a little bit of a door in the physics that's left open. So it's, it's like, do wormholes exist? No, they don't exist. Well, okay, technically.
There you go.
They probably don't exist.
You see, this is where you guys get into all kinds of trouble. You need to just be able to say no.
And then,
Move on.
It really is. It's kind of a thing where we would say, do wormholes exist? No, they don't exist. Just as a general thing, no, they don't exist. But if you're stepping back and looking, it's like, well, no, they probably don't exist. It always makes us kind of nervous to say they probably don't exist, because then, there's always somebody says, so you're saying they could exist?
Oh, that's it. You're saying I got a chance.
You're saying I got a chance. Yeah.
No.
And it's the reason is because we can't, within the limits of the physics that we understand, there are ways that you could fudge things to create an exotic matter that could possibly keep it open, but we have no idea how you'd make that. We have no idea if it exists. We have no idea.
See, from my perspective, being, honestly, all jokes aside, largely mathematically illiterate, the notion of, well, you can fudge the mathematics. You see, my notion of science is that, you've seen the same comic I have. It's like the purity of science.
Yes.
Us in the social sciences, we're way over to the left.
Right.
We're like 5 counties over. Then you get biology, and then chemistry, and then physics, and then 5 counties the other direction in the right. The pure science is math. And the mathematics. Hi, how you doing? What's wrong with you guys? Come on.
Right. And the thing is, we're not fudging the mathematics.
Okay.
There's no cheating of the mathematics.
You got to make that one clear, because people out there in the real world, you can make math say anything.
Right.
Wrong.
You can't.
You can't. I fight against that one every day.
Yeah, we're not fudging any of the mathematical methods and mathematical science there. But our assumptions, what we allow within our model, allows us to calculate with the mathematics consequences that we want.
So if a piece of the formula can have a range of possible values, and one set of values gives you the yay outcome, and the other set of values gives you the sad outcome, that's where the possibility and the fudging come in.
Right. And when I say fudging in a loose term, because in this sense what we're doing is we're playing with ideas. We're not saying that it's true.
Right.
And so we could say, oh, well, a wormhole wants to crunch off. It wants to pinch off before you could traverse it. What would keep it from pinching off? If you had some matter that satisfied these conditions. So if I assume that I have matter that satisfies these conditions,
can I make it work?
Put it in a wormhole, it works.
Yay!
I have nothing about whether or not that matter actually exists.
All we need is 15 billion tons of unobtainium, and we're going to Ganymede. Woo!
Yeah, I mean, that's it.
All right.
If you give me unobtainium, I can do anything you want.
There you go. All right. That makes sense, sadly enough. Oh, boy. So, the whole notion of black holes just scaring people.
Yeah.
I mean, they're wonderful. They're like zombies.
Yeah, they are. They're much like like
galactic
the
zombies.
Valley
Man, can we quit? Yeah, no, we got to patent it. They're galactic zombies.
Galactic zombies.
There we go.
I think because part of it is that there's such intense behavior that's happening there. I mean, a black hole can rip apart stars. It can does. And if you fell into a black hole, it would mean your ultimate demise, no matter what you do. You know, it's something that can trap you and never let you out. You know, it's like Hotel California.
Yeah,
you get.
That's beautiful. You can ask your parents, guys. Yeah.
So there's all of these bizarre things, and based upon the science that we understand, based upon the physics, they really are real. You know, we're not just making up ideas here.
Okay,
black holes exist.
Black holes exist.
Black holes exist.
In the sense that we've seen them, you know, pictures, Hubble, whatever. It's not that the math says they could exist. It's not that the Einstein's theory of relativity says they should exist. It's that, you see that picture? That there's a black hole.
They exist in the way that atoms exist. You can't see an atom with your naked eye.
Okay.
However, we understand atoms in chemistry.
Okay.
And we can use a scanning electron microscope, and we can see, you know, an array of things. We say, you see those white points on this image, those are atoms.
Wow.
But I can't hold up an atom and say this is an atom and have you see it. You can't take a picture with a photographic camera of an atom. But we can do the same thing with black holes. With a black hole, we can say here is a very intense energy point. It's got jets coming off of it. This is exactly what black holes do. Now, black holes are also dependent upon the model of general relativity. Here's the evidence we have for general relativity, how it works, that it's valid, so on and so forth. So when we see within the physics that we already understand this happening exactly as we would expect for a black hole to happen, that's a black hole.
Right.
Now, can I bring a black hole out of my pocket and hold it to you and say, that's a black hole? No. And so we can't do that, but we can say, here is evidence that we say black holes exist, black holes exist.
It still astonishes me every time we do stuff like this, the level of similarity between your discipline and mine that you just never expect. You have just described exactly the problem with defining intelligence. It's exactly the same problem.
And yet they call you not a science.
Well, yeah, you know, but, you know, we're cute, we're friendly, you know, we're a little frenetic, and people put up with us most of the time. But it's the same problem.
Yeah.
I can't show you intelligence. I can't show you a picture of intelligence. What I can do is show you evidence of intelligent behavior and say, if you've got a brain or an individual that can do this, do this, do this, and do this under these circumstances, you call that intelligence.
Right. But honestly, at the same time, I mean, psychology gets a bad rap for being not a science. Because you can't repeat your experiment exactly.
And we're probabilistic. That's the other problem.
Right. Things like astronomy and astrophysics, for example, also get the same rap. There are people who say astrophysics isn't a science. Now, usually these are people that have a different opinion in terms of things like the age of the universe. But the idea is that, well, all you're doing is looking. All you're doing is taking observations and then fitting it to a model. You can't create a black hole. You can't build planets. You can't watch them over billions of years. So you're just
That's a 16th century. That's a 16th century understanding of what science is.
Well,
I mean, what they're saying is, if you can't take sodium and chloride and make salt, you're not a scientist.
But this is one of the things. I mean, it's kind of like classic Popperism, the idea of Karl Popper, that if you cannot repeat your experiment, if you cannot disprove your model, then it's not really science. And things like psychology and astrophysics kind of fall into that, when very clearly we can compare models to this thing and this thing and this thing, and we can, even though they're completely different phenomena, you know, this black hole is not another black hole on the other side of the universe, but we can look at these similarities between the two and we can see how they compare to the model in the same way that you would do two radically different people.
Right.
You can infer some similarities based upon broad cognitive models.
Yes, and we do.
I've been talking with Dr. Grant Gutheil, Associate Professor of Psychology at Nazareth College in Rochester, New York. Our program is produced at Rochester Institute of Technology with support from the RIT College of Science. I'm your host, Brian Koberlein. Thanks for listening to One Universe at a Time.